All right, this is lesson 1-5 for geometry. The title of today's lesson is Perpendicular, Bisector, and Copying Angles. Everything that I'm doing today is making a construction. I'm constructing a perpendicular bisector, and I'm constructing a copy of an angle. All right, we're in Standard D today, so class, what is Standard D?
Constructing lines and angles.
Say it louder, D3.
Constructing lines and angles.
All right, constructing lines and angles, thank you. So we have our setup. Our first section is called diagrams. So these three words, sketch, draw, and construct, they mean very specific things in geometry. So I just want to give you a brief overview for what each one entails. So sketch, the main thing you need to know for this is there's no tools required. And I'm going to have trouble spelling here, of course, tools required. So if I say sketch a triangle, just go ahead and do your best to make a triangle without ever using a ruler, no tools at all, just your pencil. You do your best. So draw. This actually does have tools. Both draw and construct have tools, but they use different tools. So draw a type of question, and we can do like little examples down here, but draw, you're usually going to be using a ruler, which should surprise us because Mr. Sindel just yesterday said the classic person in geometry will only use a straight edge and a compass. All of a sudden I'm saying ruler. So hopefully we're shocked. Ruler. Ruler and a compass. Not a compass, sorry. This is going to be a protractor. Ruler, comma, protractor. And construct, this is the main point of geometry. This is going to be a compass and a straight edge. So you don't actually need to do all three of these examples because I didn't give you guys a protractor, so we can't really do it. I mean, we can try to estimate, but here's an example. So we'll label these examples. So our first example, I want you to sketch a square. My pen doesn't like my computer for some reason. Sketch a square. All right, go ahead and sketch a square, guys. So you're not allowed to use any tools, just your pencil. Of course, if I was doing this with pen and paper, it might be a little bit neater. There's my sketch. And you're allowed to say, okay, well, those are all equal in your sketch. And then here's another example, 2. Draw a line that is 2 inches. There you go. So what you'd use for this is you take out your ruler. So you'd have a nice straight line. I didn't say line segment, so be careful here. A line that's 2 inches. Well, I don't have a ruler on me, but I'm going to say that that was 2 inches. So I'll make a note here because I'm in my electronic version that I use a ruler. And I guess technically this is really, really sloppy mathematician work. Does anyone want to tell me why this is really bad to say have a line that's 2 inches? If I said line segment that's 2 inches, that would make a lot more sense. So what's wrong with this statement?
Because lines go on forever.
Yeah, lines go on forever. So that was very sloppy of me, and I apologize. Does that make you shudder to see Mr. Sindel do that? No? All right, well, we're dead class today. We'll go to number 3. All right, so, and this one, you don't have to do, because we did this yesterday, but just an example of a question is construct an equilateral triangle. And this is going to take too long. I don't want to actually put it in the notes, but we know how to do that. Maybe you want to come back and add it in your notes, how to construct it, but maybe you just want to have a note here that says see previous page, or I don't know, something like that. because it's going to be using the compasses that we use. You'll make 3 circles in the way that we learned yesterday, and you'll make your equilateral triangle with the intersections of those circles. All right, moving on. Once I see all pencils, stop writing. All right, so next slide. So I want to just do a copy of a line. So we'll title this section Copy a Line. Line segment, to be precise. I want you guys to make a line segment. With your ruler, with your straight edge, make a line segment somewhere. It doesn't have to be straight, or it doesn't have to be parallel to the paper. I mean, it has to be a straight line, but it doesn't have to be parallel to anything. You can kind of draw it diagonal like this. And again, the way that we denote that it's a line segment is you have these little points at the end. I want you to copy that line segment. What I mean by that is I want to draw the same length of line only using your compass and your straight edge. So I'll write the problem down in our notes too. I want to copy this line segment only using a ruler, or not a ruler, I'm sorry, straight edge and a compass. Straight edge and compass. All right, so you do your best. How are you going to do that? I'll give you guys a 20-second lead on me. See if you can actually copy that line only using those tools. Doesn't have to be the exact diagonal, just has to have the same length. So I should see people picking up their compasses and trying this out for themselves. So this tool is going to be hard to use for geometry because I can't get the circle the right length. Can I change the color of the circle? Oh well. So what you should do, if you haven't figured this out already, is you make your compass the exact length from your first point to your second point, and then basically just draw that same circle somewhere else. Draw that same, come on now. Draw that same circle somewhere else, and then just draw a line through that circle. And that line could be coming down like this. Bam, we copied a line segment. Easy peasy. It's about to get a little bit more complex. All right, and I'm realizing that I need a lot more space, so maybe I should do one construction per slide. So it's going to be really spaced out in the notes. Okay, I want to title this next section Perpendicular Bisector. I want to start talking about perpendicular bisector by just talking about what these words mean. So, perpendicular. And what do we know about perpendicular? Can we just draw a picture in our notes? So with your arms, can you show me what perpendicular means? Yeah, exactly. Everyone's making the cross that was doing it. There's Gio finally doing it, and Chris is just too studious. Yeah, so perpendicular means you have lines meeting at right angles. And they could be like this. If you have an angle like this, then it's still going to be a right angle. And you can actually note that it's a perpendicular because you'll have one right angle. one right angle. And the word bisector, what does that mean again? Quiet raised hand, bisector. Or to bisect. What does it mean to bisect? Bisect, guys. No one knows what bisect means? All right, well, if we don't know, I'll analyze this even further and slow us down even further, but here we go. So bisect, bi. What does bi mean? Two. Yeah. And then sect is to cut. I think it means to cut. That's what I've always interpreted it as. So bisect means to cut in two. So the official mathematical definition, or at least something that's a little bit more reasonable in mathematics, is to, I'm going to use the word cut just because I like the word cut into two equal halves. And halves is spelled with a V. So this could be talking about an angle. I could cut the angle into two equal angles. I could cut a line into two equal line segments. But regardless of what happens, you're cutting it in half equally. So a perpendicular bisector is going to cut a line segment in half. And not only is it going to cut, because I can cut it in half, and don't write this down, I can cut it in half by cutting it like this. Like this line segment, we'll call this A, B is cut in half, but this line is not perpendicular. I want a line that cuts it perpendicular in half. We understand what the object is? Thumbs up, thumbs down? Okay, so here we go. So start by drawing a line. Segment, sorry. Not a line, but a line segment. And this is going to take up a bit of room, so you might want to move it down a little bit. A line segment. So this is one of the easiest constructions. You literally have to draw two circles, and then from those two circles, you're going to draw a line where they intersect. So it doesn't really matter the size of the circle, but the circle needs to be at least halfway. So it can't be halfway exactly. It needs to be a little bit longer. So if I'm talking about this as my center, point A as my center, maybe I should come back and say, label these. This is going to be point A and point B. If point A is my center of my circle, then that circle is going to come out like this so that it goes beyond halfway. That's really the only rule. They can be infinitely, almost infinitely large of a circle. It'll still work, but it has to be at least halfway. Okay, so here's my circle. Let's go to my circle tool. And make A the center of that circle. So I'm going to guesstimate that it looks like right there. And then, while keeping the same distance with your compass, you don't change the width of the compass, draw another circle with B as its center. You should see that the circles intersect at 2 points. So go ahead and label those points. Maybe I should do it in a different color so it's more clear in the notes. We'll do it in red. So 1 point here, 1 point here. I'm going to call this point C and point D. Now with my straight edge, I'm going to connect lines or connect points C and D. So with your straight edge, connect C and D. Okay, my circles are a little bit off here. What's going on? Oh, I see. Because my points are a little bit too big, so I'm not getting the exact intersection of the circle. And what you have just constructed is a perpendicular bisector. All right, so far so good. That was easy. Today is all easy stuff, and I promise it does get harder, unfortunately. All right, so let's try to get those steps down so we can remember it for our notes. What did we do? I double clicked, okay. What did we do? What was step 1? We drew a circle. So these are the steps. So we want to, I don't like the word draw because we're not doing a drawing. This is a construction now. So construct around first point. And what was our note? What was the size of that circle? Does anyone remember? All you have to do is regurgitate here, guys. The radius of that circle. What about that radius? What was the size of the radius?
Half the diameter.
What do you mean by diameter? The diameter of the circle?
Yeah.
Oh, so you're just talking about the rule, then that radius is equal to half of the diameter? Yeah, so you're correct in saying that. But in order for the construction to work, though, the radius has to be a certain size. It has to be bigger than something. Do you guys remember what that bigger than was? Because if I had the circle that was this size, and I'll draw something that's incorrect here, so please don't copy this down. If I drew a circle that was maybe this big, and I have that as my center, and I have the same circle around A, those circles will never intersect. So what is the size that they need to be? Because I have to get the circles to intersect, otherwise I can't get those 2 points. I can't get points C and D. Do we not know, or are we shy? And because you aren't answering, I'm not going to get the answer to that either. Guys? Oh God, okay. Well, I'll just give it to you. We're taking too long. The radius needs to be large enough to intersect that's really the only key. If you drew it too small, like these 2 green circles, if I didn't have those black circles and I only had the green circles, then those circles wouldn't intersect. So make the radius big enough to intersect. Step 2. Same circle around second point. And then the final step 3, I really want to have someone participate for step 3. What was the final thing that we did? After we have those points C and D, those intersections, we did what?
Connected them.
Yeah, we connected them. To make what shape? What is this thing called?
Line.
A line, yeah. So I'm going to write that down. Make a line through intersections. And this is a T right here, intersections. All right. And our last construction for today is copying an angle, and this is the hardest thing that we're going to be doing today. So title this, Copy an Angle. So with your straight edge, go ahead and make an angle. Have 2 line segments. in some angle. That's not the color that I want. I'm going to draw a really surreal angle because sometimes people make it too easy on themselves by making both line segments the same length. That doesn't always happen. This is one of the hardest things to copy. So you guys all have an angle. All right, get your compass ready. What I want you to do is to, I guess we should label some points really quick. I want to call this point A, and call, if you do have my exact angle, call the shorter one B. We don't really care about the longer one. I mean, if you want to, you can call it C, but we're not going to use it at all. So I'm copying the angle BAC. Here we go. So with your compass, make a circle with center A that intersects B, which means the vertex of the circle, or I'll just draw it here so we can see that the vertex of the circle goes through B. And it's really difficult to do on Mr. Sindell's computer. Here we go. Needs to be slightly bigger than that. All right. All right, so we're going to call this second intersection, just label it another letter, D. All right, so we still have our compass. Don't change the width of the previous circle. What I want to do now is to draw a random line. So, or line segment, sorry. So draw another line segment, and it would be better to draw it something that isn't exactly the same angle as this line. So I don't want to do this exact angle here. I'm going to maybe change it up to make it a flat line. Something slightly different so we can still see what's going to happen, but it's not going to be exactly the same starting line. We'll go from the other end of the alphabet. We'll call this point Z. Okay, now what I want to do is to copy that same circle around point Z. So Z is the center. Go ahead and copy that same circle. This is where technology actually comes in handy. So copy, paste, circle with center around Z. Maybe I need to move this a little bit up. All right, so we're going to call the intersection of this circle on this line. We'll call it Y. So generally, we know what we're looking for. Somehow, when we're copying this angle is being copied down here. Somewhere we're looking for a point along this circle that's going to be right in this area generally. So generally up here. So how can we find where this point is? And I'm going to pause here and let us think. How the heck can we figure out where this next point is? Is it there? Is it there? Where is this next point going to be? And how can we figure that out?
Why don't you just make a circle from point Y?
From point Y? Yes, so we're going to make a circle around point Y. You're correct. But how do we know how big that circle is? And before anyone else jumps out, I want to give us at least a solid 20 seconds of thinking. So without shouting out, how can we make a circle around point Y such that we get the exact distance to point B? So if you have the answer, then you can look at me. Otherwise, we should be trying to think about how the heck we find that. Chris has it?
Well,
right, you guys can look at me. I'm sorry, I didn't mean that you couldn't look at me. All right, who wants to take a guess? So Chris has the first part. But how many people think they have an answer? So Fiona has an idea. Is there anyone else that has an idea? It's okay if it's wrong. Like, that's how math works. You're wrong, and then you'll find something that doesn't work. Anyone aside from Fiona want to take a guess? All right, Fiona, what do you have for us?
It'll be the same distance from D to B.
Exactly. So repeat it one more time. Make sure people digest that.
Like, make your compass the same distance from D to B and then draw a circle around Y.
All right, so go ahead and do that. I'm going to repeat into the microphone since that was so crucial to this copying of an angle. We're going to measure the distance from D to B with our compass, and we're going to make that radius circle around point Y, and that will make sure that we have the same distance from Y to, I'm guess, ZY, X, so it'll be X up here somewhere. And I haven't said this explicitly yet, but you don't need to make the entire circle. I've been making the entire circle to demonstrate that we're using a compass, and it's easier that way. If I had a digital compass somewhere with this program, I would just be marking this little part of the circle up here, so I don't have to draw the entire circle. In fact, when I give you a quiz or when I give you a test, I'm going to let you see someone's diagram that they've used to construct something, and it's only going to have a few little tick marks. It's not going to have the entire circle. So you need to be ready to see stuff like that. All right, but I'm falling behind here. I need to make sure I get my ellipse done. That looks about right. So that's centered around D. It needs to be a little bit bigger. All right, that looks good to me. Center that around Y. And then the intersection. And what's kind of cool here is you can make either intersection work. Both of these intersections can be made points, and that will still be the same angle. I think I'm just going to try to be consistent and have that point above it so we can see clearly what's going on. There's going to be a point up here. I'm going to call that point ZYX. And then I'm going to draw a line from Z to X. And that line doesn't have to be a line segment. It can go all the way through. So even though our lines have been rotated in my example, this angle right here, and I can do this in a different color, this angle right here is the same angle as right here. We just copied it. All right, let's try to make those steps explicit for our notes. What did we do? I guess we kind of did it a little bit out of order. Step one was to just get this line down. So draw a line. All right. This is where you guys have to remember back to what we did. What was the second thing that we did? It was actually the first thing that we did, but what comes next? We drew our line. What comes next? All we have right now is this line. We have this point labeled Z. What was the next thing that we did to make sure that we had our first circle set up? Come on, guys, you got this. This is just remembering back to what you just did 5 minutes ago. No? I haven't heard from Stephanie or Gio today. Not D3, but Steph. You guys?
Circle around Z.
Yeah, so how do we make sure that we have the right length? But you're right, we have a circle around Z.
You use the same diameter you used on A.
Yeah, so what did we measure? We measured from A to
Z.
I hear people whispering it to you. What are they saying?
A to B.
A to B, exactly. So we measure the distance from A to B. So measure from, I'm going to call this the first point because A was our first point that we had. To shortest line. That's a line, but here we go, line. And then once you have that, you draw, I think this is all technically step 2. This is making the first circle. So I want you to draw that same circle around point on our new line. All right, so right now what we have is we have a giant circle around A, a giant circle around Z, so our next step was getting Y. How do we get Y? That's an easy question, tossing it up there. So this is number 3. I don't know if label is the right word, but we'll say, yeah, we labeled this point. And how do we get this point?
Draw the circle across the line.
Yeah, exactly. So we need to label where, I'm just going to say circle crosses the line. And then lastly, we have step 4, which was Fiona's method of guaranteeing that we have the right distance between y and x. So I know Fiona knows how to do this since she came up with it. Can anyone else remember how Fiona found the distance from y to x? What do we do with this diagram up here to find the same circle that we made down here?
Wouldn't it be from D to B?
Yeah, exactly. So, what's going on? So, measure, and I'm just going to be, so far I've been pretty general. I'm just going to say measure DB, measure the distance between DB, and make circle around last point. And step 5 is really simple. I can do it in one line. Make a line. That's where we made the line ZX. So those are pretty general rules. We might get those refined a little bit further, but those are the general rules for copying an angle. All right, so we get out of here at what, 10:06? Oh wow. Go ahead and write those summaries. All right. Everyone say bye to the people in the video.